it's time to go to the store.
Stop right there.
Wait, what?
Well, sir, to go in, you must check in.
Well, I can check in with my
Trace together token.
Here you go, sir.
Thank you, sir.
Here you go. Thank you, sir. Let's go into the store.
But sir, you're forgetting something really important.
What now?
Don't shoot me! What did I do wrong?
Aha, don't worry, sir. It's just a...
Infrared thermometer.
It helps to take your temperature. But now I wonder, how does it work?
Oh, you almost got me there. I thought you were going to shoot me.
Aha, sir, you're really funny. Wait, what the...
So infrared thermometers, you may have seen them at airports, and surely you must have seen them at malls. And you may have wondered to yourself, how the heck do they work? Well, first we need to understand the uses for infrared thermometers. So according to that moron who just shot me, infrared thermometers help to measure the temperature of your body. Well, he's kind of true, but infrared thermometers actually help to measure the surface temperature of your body or an object. From a distance, of course. So there's a wide variety of infrared thermometers, and the distance from which they can measure temperature varies depending on the thermometer itself. So for example, some infrared thermometers can measure temperature from thousands of kilometers away, and those infrared thermometers are used in astrophysics and astronomy to measure the temperature of celestial bodies such as stars or planets. And some infrared thermometers can measure temperature from teensy distances, such as a fraction of an inch away. And those infrared thermometers are used in malls, for example, to measure the temperature of your body. Infrared thermometers were originally used to measure the temperature of dangerous objects, such as molten metal at a steelwork. This is because infrared thermometers can measure temperature from a safe distance. So this brings up the question, how the heck do they work? It works on a phenomenon called black body radiation. Okay, I know what it sounds like, and I don't mean it that way. Just give me a bit of time for me to explain. So anyways, any object that has a temperature above absolute zero has atoms and molecules inside of it that are vibrating really fast. So as the temperature of the object increases, the vibration of the atoms and molecules also increases. So as they vibrate, they emit something called infrared radiation. And in essence, that's the black body radiation that was mentioned before. So what is infrared radiation anyways? Well, infrared radiation is a type of electromagnetic radiation, and it has a wavelength that is longer than that of visible light.
I didn't understand a single thing you said. Could you put it into simpler terms, please?
Well, you can put it into simpler terms. If you've ever seen a piece of metal being heated up before, you'll notice that after a long period of time, the metal will glow a dull red. And after a while, it will glow orange. And if you just wait long enough, it will glow a white color. This is when the temperature of the metal has exceeded the infrared spectrum and has gone into the spectrum of visible light. Hence, the metal is glowing in a particular color. So right before it glows a dull red, it is still in the infrared spectrum. Hence, the piece of metal is very hot. However, it's not glowing in any particular color.
Well, if we're unable to see infrared radiation, then how is the infrared thermometer able to detect it?
Well, let's take a look at this. Here I have a magnifying glass, and here I have a torchlight. I'm going to shine this torchlight onto this wooden door. And as you can see, the light is being spread out across this large area over here.
However, when I put my magnifying glass between the door and the torchlight, and as I bring it closer to the door, you can see that the light is being focused onto one singular spot.
So since visible light is also a type of electromagnetic radiation, we can say that since visible light can be focused with a lens, infrared radiation too can be focused with a lens. Thus, there's a lens on the infrared thermometer that helps to focus the infrared radiation onto a detector. This detector is made up of something called a thermopile. The thermopile helps to absorb the heat or this infrared radiation, and it sends a voltage output. This voltage output is displayed as the temperature reading on the infrared thermometer.
Wait. How does a thermo thingy convert heat into voltage?
It's called thermopile. It's a pile of thermocouples arranged in a series. Well, let's find out what a thermocouple is. A thermocouple is made up of two different metals with different conductivity, which are joined together at one end to form an electrical junction, and the other ends are connected to a terminal block, and then connected to a voltmeter to measure the voltage difference between the two different metals.
But wait,
You again?
why do we need to calculate the voltage difference between the two metals, and why do the metals need to be different?
Well, I'll come back to that in a second. But first we need to understand how the heat is converted into a voltage output. Imagine we have a copper rod over here, and either side is labeled side A and side B. And side A is currently being heated up. So, as side A is being heated up, we know that the heat will travel from the hotter end to the colder end. So from side A to side B. So essentially what is happening here is that the atoms that make up the copper rod begin to vibrate more and more. And since the object we're heating up is a metal, it has free charge carriers, which is the sea of free electrons. The vibration of the atoms allow the electrons to move more easily, and the electrons begin to move towards the cooler end of the rod. This is due to the temperature gradient. This is a difference in temperature between both ends. Hence, there will be more electrons in the cooler end compared to the hotter end. Now, since electrons are negatively charged, the cooler end will be slightly negatively charged, while the hotter end will be slightly positively charged.
Voltage is like pressure.
In both measuring pressure and voltage, we always measure the potential difference between 2 points. When measuring the pressure of water flowing through a pipe, we always measure the pressure inside the pipe and compare it with the pressure outside the pipe, which is the atmospheric pressure. So if no water is flowing through the pipe, the pressure gauge will read as 0. This is because there's nothing to compare it with, as the pressure inside the pipe is the same as the pressure outside the pipe. It's the same thing with voltage. If we read across a 1.5 volt battery, we will get a measurement of 1.5 volts. However, if we measure on the same ends of the 1.5 volt battery, we will get a reading of 0 volts. Back to the thermocouples. If we connected the same metals, for example copper, when we apply heat to the electrical junctions, the electrons will naturally move towards the colder ends as there's a temperature gradient. However, since the copper metals are of the same conductivity, the electrons will build up at the cold ends at equal amounts. So both wires will conduct heat equally, and the temperature gradient will be the same. Since there's no voltage difference between the two wires, the voltage will read as 0 volts. However, when we connect two wires of different metals, hence different conductivity, the two metals will conduct heat differently. Hence, the temperature gradient of each metal will be different from one another. Hence, there will be a voltage difference between the two metals, and the voltmeter can finally measure a voltage. To make it a useful tool, we calibrate it by testing it against a known temperature and marking down the voltage generated. Then we use a formula to calculate the temperature from the measured voltage. We must submerge the cold junction into an ice bath, which we know has a temperature of a constant of 0 degrees Celsius. That way we can get a voltage which has a reference relative to 0 degrees Celsius. This method is used in science labs, however it's not as practical to use it in engineering, or in our case, the infrared thermometer. So instead, to improve the accuracy, we leave the cold connections at equal ambient temperature. Then we measure the temperature and apply a formula to offset the error. To measure the temperature of disconnection, we use a tool called the RTD temperature sensor, and this helps to offset the error. So understanding the RTD temperature sensor is a whole nother video, and sadly this video has come to an end. However, we have understood how a thermocouple works, and finally we can understand how the detector is able to convert the heat into a voltage output quite instantaneously. But you may be asking, well, why do we need so many thermocouples in a thermopile? Thanks, little Sanjay. This is because the voltage generated by one singular thermocouple alone is really small. Hence, to amplify it, a series of thermocouples are used. So now you understand how a thermocouple works, how infrared thermometers works, and a little about the uses of infrared thermometers. Thank you for listening.